The next presentation will be given by Dr. Aaron Ramakrishnan, who is the Chief Technical Officer of Sono Motors in Germany. And Dr. Ramakrishnan, if you can go ahead and share your screen, that would be great.
Okay, just a second. I hope Google Chrome. You got it?
Yes, we can see it. Thank you.
Good. So first of all, I have to correct. I'm not the Chief Technology Director of Sono Motors, but again, we are pushing towards a lean organization. So that's why everybody at Sono Motors is driving the VIPV technology revolution. Okay, let's start. And so we probably all agree that the combustion engine are in the past, and the future will be definitely electrical vehicles. And you can see it's actually happening. So it's the present. And you can see very nicely that electrical vehicles have to be charged. And so the future, what we think at Sono Motors, the sustainable future, will be the integration of photovoltaics into electrical vehicles. Why electrical vehicles will revolutionize the automotive industry? We think that three things are very important to realize the VIPV. That's sustainable storage, the sustainable energy generation, and the transportation. And this is actually all implemented in our car, which we developed. It's called the Zion, which is a solar electric vehicle. And with our data, we could figure out that on a sunny day in Germany, you could get about 30 kilometers per day. So that is the basis. So let's look at India later. And now, first of all, let's focus. Why is it important to implement photovoltaics, although the area of a car is not that much? So we have done a comparison of electrical vehicle and a solar electrical vehicle, which you can see here. On the y-axis, you can see the remaining kilometers in the battery, which starts with 200 kilometers. And now you can see the electrical vehicle has to recharge on Sunday. It will be recharged, and then it has to, again, although on the weekend you won't drive further, you have to recharge it on the third Sunday, and so on. So you have 4 points of recharging. Now, if you look at a solar electrical vehicle, you can see that the sun, for a standard commuter, which is less than 20 kilometers in Germany, is actually charging the battery during the week. And during the weekend in Germany, you go for a vacation, you will drive a longer distance, you discharge the battery and actually invest the energy in the battery to drive. And if you look at the comparison, you can see that you actually have 4 times less charging point than compared to a standard electrical vehicle. So that is a very nice advantage of a solar electrical vehicle compared to a standard electrical vehicle. How about India? 75% of Indian commuters, they travel less than 35 kilometers per day. And now we did some modeling in New Delhi. So you can see in the first graph, you can see the kilowatt hours per day, or actually per month in average. That's January, February till December. On a low, as you know, in Delhi, you got a foggy or a not very nice clear sky. So in average, you get about 3.2 kilowatt hours per day, which corresponds to 22.7 kilometers per day. But if you say everything is solar, then you probably have a beautiful sky in New Delhi. And that's something I really hope to see someday in New Delhi, that you can get up to 5.1 kilowatt hour per day. And this actually corresponds to 36.3 kilometers per day. And that is already a lot more than the average commuter would need in India. So that's why it makes a lot of sense to go for vehicle integrated PV. How can you now implement solar into electrical vehicle? So I'll just give you an example how Sono Motors did this. We started to make our first idea in 2017, and I would call it's a PV applied. PV is applied to the vehicle. So you can see very clearly that the solar cells are put on top of the body. So the next technology development is to integrate the photovoltaics into the body, and this is one of the key technology points at Sono Motors, that we want to make the body, the PV part of the body, and like that also reduce the weight, which I'll show later. We call this technology VI Sono. So as I told you, integrating photovoltaics into the body makes sense because at the end we integrate it into a polymeric matrix, which will give you an outline that you can get even lightweighter than a sheet metal body, as you can see in this graph, which is about 5 kilograms per square meters. And the VI Sono eventually will have less than that. So that means we also reduce weight. I also have given you example for flexible PV and flat glass PV, which is somehow the standard now to implement photovoltaics into vehicles, and the glass VIPV, which is now we have in the market. The next thing is we are going to implement a new kind of solar cell technology, which I'll do shortly, and which will have about 220 watt per square meters. So again, let's look at the different technologies we have in the market. So the standard technology is the busbar-based technology, as you can see in the graph here on the left side, 2018. That's what we implemented there. Then we went for a new kind of technology using a backsheet. That means we're having the wiring on the backside of the solar cell, which is a metal wrap-through technology. As you can see, we can still see the top contacts on the solar cell. But now it's very interesting, and this will be the technology we'll use for the next prototype. We're getting the contacts on the backside, and it's called back contact solar cell, or interdigited back contact solar cells. And that is really amazing because the aesthetical advantage you can very clearly see, and it really integrates very finely into the body of the car. Next improvements, what we'll do is half cells, and maybe the solar experts, you know that if you go to half cells, you can actually increase the voltage for a smaller area, and also you can decrease the losses because of a lower current you can drain out of the half cells. So that will be the next. And here you can see a CAD where it will be implemented in all parts, in the hood, in the side doors, and also on the top. So everywhere where there's area, solar cells will be implemented, and like that we can increase the solar energy harvesting in the car. The next thing what we are working on, or actually we already have our first prototypes, it's called the multi-channel power tracker. So and that is really nice. We already have efficiencies more than 94%, and actually slowly getting to 96%. So that is happening. The maximum power point tracker actually tracks when the car is moving, so that it always gets the maximum out of the solar cells. So already the tracker efficiency is at 99.9%, which is really amazing. Why am I showing this? So we have worked on the body integrated PV, which you can see on the left side. We have worked on the electronics, which is the MCU, which is providing the CAN and the BMS communication. That means the battery communication. We want to charge the battery, but also the energy is efficiently distributed in the car, or maybe into the grid, which I will show later. And most important, the whole hardware is integrated into the car. And that is very important because at the end, the car has to be safe and it has to be functional. Last but not least, the whole thing will be solar optimized with the software and an infotainment to increase the user experience of solar energy. What does it mean? So everything is now optimized in the car. Now we have to look on the outside. So we are using a model like where is the car, at which point, at which area is there shading from buildings, and all this has to be modeled so that the car will find the right positioning to get the maximum solar energy out of your environment. And that is really nice because this will be actually reflected in the infotainment system, which is a unique solar user experience because we are combining VIPV and digitalization. And so you get from live and historic data, you can visualize where you get the maximum solar energy out of your car. And since you're using all the body parts of your car, you can really optimize to get the car in the right position so that you can get the most out of the sun from your car. So this actually solution is not only working for automotive, it also could work for other kind of applications or other vehicles. So let's go crazy. So we could imagine trucks or even trains and even boats with this kind of new body, solar integrated body panels, and every vehicle has certain requirements, and with this kind of technology, we can solve the requirements needed for any kind of vehicles. So we already have LOIs signed by companies to realize this kind of concept for other vehicles.
Sorry, we have 7 minutes for 2 presentations. How do you intend to work it out? Sorry.
Okay. All right, perfect. So I'm already done. So let's go totally crazy. So the thing we should think about is an e-rickshaw. So an e-rickshaw would be absolutely amazing with this kind of technology, and we would have also a very nice way of really have a clean surrounding, no sound and no emission. So thanks for your attention, and I hope the VIPV will materialize in India.
So thank you for an excellent presentation. It's so exciting to think of being able to have a car that can refuel itself while it's sitting parked in the sun.